What force is required to stop the car just on the stop line? Looking at this image, what force do you think will be required for this car to stop just at the stop line? If you are following us, you will discover that in our previous video, we solved part 1 of this problem. And in this video, we are going to be looking at part 2, which is calculating for the force required to stop this car just on the stop line. For us to calculate the force that can stop this car, we must know the work that will be done to stop this car at the stop line. When we know that amount of work, we can then calculate the force required from that amount of work, having known the distance. So we want to calculate first the amount of work to be done. But one thing we have to put at the back of our mind is that the kinetic energy of this car will be overcome for the car to stop. In other words, if we can evaluate or calculate the kinetic energy of this car, that is because this car is moving, so it possesses kinetic energy. The kinetic energy of this car will definitely be equal to the amount of work that will be done to stop this car. So while we are looking for the amount of work, we just simply calculate for the kinetic energy of this car. The formula for kinetic energy is given as half mv squared, m for the mass and v for the velocity of the car. So the mass of the car is given as 1300, and we plug in the values now. The kinetic energy will be equal to half times 1300 for the mass times 10 squared. 10 is the velocity, as you can see here, and we have the square of the velocity. So if we solve this by putting it into the calculator, we'll find out that the kinetic energy of the car is 65,000 joules. Like we mentioned previously, the kinetic energy of the car will be equal to the amount of work that will be done to stop this car. So technically, this is the amount of work required to stop this car eventually. But we want to know what the stopping force is. What force can stop it just on this stop line? And we know the distance from the car to the stop line is 23 meters. Also, we know that the work done is given by the product of force and distance. So if we pick this distance and multiply it by the force we are looking for, equate it to this amount of work, we can be able to calculate the stopping force. In other words, I'm simply saying that this kinetic energy will be equal to the product of the force required to stop the car times the distance we want the car to stop by. So if we put in the values, the kinetic energy we just calculated is 65,000, and that is equal to the force we are looking for times 23, which is the distance over which we want this car to stop. If we want to calculate for force F, we have to divide both sides by 23, therefore making F the subject of the formula. And if we do just that, F will be equals to 65,000 divided by 23, which brings us to 2,826 Newton force. This is the amount of force that is required to actually break this car down in a distance of 23 meters for it to stop on the stop line. It is very simple, and I have a simple one for you. What do you think? With what uniform retardation will the car stop on the stop line? Previously, we said that the retardation of the car was 2 meters per second square, and it couldn't stop in 23 meters. At this point, we have been able to calculate the stopping force that will make it stop at 23 meters. Can you now tell us, what do you think the retardation would be for this car to actually stop on the stop line? It is very simple. When you calculate that and you get the answer, please put it in the comment section, and I will be there waiting for you. Please follow our page if you have not done so, and also subscribe to my YouTube channel because I've added the link to the YouTube channel in the description of this video as well as in the comment section. Keep encouraging us, and we will keep bringing to you interesting contents. Thank you very much for watching, and see you in our next video.